Hello, my name is John Maddog Hall, and I'm the board chair of the Linux Professional Institute. My talk today is simply entitled, What Next? Because people are kind of interested in what's the next thing that's coming down. I started programming in 1969. I was a university student. I was going to Drexel University in Philadelphia. I actually wanted to become an electrical engineer, but I was almost electrocuted by 13,600 volts and 800 amps, and I decided that somehow this new thing called software programming was a better thing for me to do. While I was at the university, I ran into an organization called DECUS, the Digital Equipment Corporation User Society, and these were users of DEC's equipment who wrote and owned what they wrote to solve their own problems. But after they wrote the code, they said, well, what am I going to do with this? Because selling software is actually quite hard. And these people were not in the business of selling software. They were physicists and electrical engineers and university professors and so forth. And so they contributed their software to the DECUS library. And then DECUS would make copies of the software and send it out on paper tape or magnetic tape or other means to whoever would purchase it, basically for the cost of reproduction. And so, as a university student, I could look at the catalog from DECUS and I could say, oh, I want a new copy of this text editor, and I would send out my $5 to DECUS, and eventually it would send me back this paper tape that I would use in my computer system to program it to use a text editor. Now, $5 back in those days was a lot of money. And, as a university student, I would say, well, for $5 I could get this text editor, or I could get 10 pitchers of beer, because beer was only 50 cents a pitcher back in those days. And this was a real problem, a real struggle for me. But because this was free software, once I had my text editor on paper tape, I could go to the school store, get some new paper tape, make 10 copies, and sell it to my friends for $1 a piece. That made up my $5 I spent for the text editor and purchasing the paper tape, and a little bit for my time, and then I could still get my 10 pitchers of beer. So, in a way, I was the first Red Hat software. And I did other things. I created the first computer club at Drexel and things like that. But I was really impressed by DECUS and the quality of the software they had. Now, why these people give away their software? Well, as I said, they were not in the business of selling software. They were in the business of doing whatever they were in the business of. But when they gave away their software to DECUS, sometimes they would go to a DECUS meeting, which was held twice a year, and they'd run into people and they'd say, oh, you the person who wrote that software. I really liked it. It really helped me out. I really appreciate that. Let me buy you a beer. Or let me buy you dinner. Or, gee, you did a great job on that. Would you like to come work for me and write software for me? And these are all the reasons why people write free software today. Plus the fact it's actually fun to write software. It's like a puzzle, and solving a puzzle is really great. Now, back in those days, too, there was no such thing as copyright on software. If you wanted to sell your software, you would have a contract. You would write a contract between you and the purchaser of your software. And this would take a lot of time, usually with lawyers involved and so forth, because a lot of times the software that was sold back in those days, commercial software, you might pay $100,000 US for a single compiler to go in a single system. And that was $100,000 in, say, 1973. I know this because I negotiated some of those contracts back in 1973 when I worked for a company called Aetna. And this was the software was protected by contract law, same type of law that you use when you do work as a contract or whatever. But it was always started off with lawyers, and it cost a lot of money. So, it wasn't until much later, around 1976 or 77, that copyright and patents started to be applied to software. Now, when I worked for Aetna, it was the largest commercial user of IBM equipment in the free world, which goes to show if you use enough adjectives about yourself, you can be the best of anything. I am the most handsome, white-bearded, white-haired computer guy who's talking on this video right now. See how that works? But Aetna was so big, and they bought so much of IBM equipment, that they demanded to get the software, the source code for the software they used, and they got it. And the companies that knew that they were negotiating with Aetna would say, well, if we don't let them have the source code, they're not going to buy the software. So Aetna had all the source code, and as a young programmer at Aetna, I got to see this software. I actually got to see the source code for IBM operating systems and IBM compilers and other things, databases and things like that. So I learned a lot from seeing that software. Later on, after I got my master's degree in computer science in 1977, I went on to work for Hartford State Technical College. And once again, I ran into DECUS because HSTC had DEC equipment. We had a PDP 1170, we had a PDP 1134. The PDP 1170 wrote a closed source operating system called Vistus E, but there was a lot of software which I got from DECUS, again, just at the price of copying. And so I enjoyed doing that. I enjoyed showing the software to my students, and my students enjoyed seeing it. After I left HSTC, I went to work for Bell Laboratories, and of course, they're the ones who wrote Unix. And once again, I was put into the position of working for a company who produced the source code for the operating systems that they used. They produced the source code for a lot of the applications that they used. And I got to see that source code. I got to learn from it. Eventually, I left Bell Labs and went to work for DEC. And I went into their Unix group. Of course, DEC was a system vendor. I was working on their versions of Unix, and again, I got to see the source code. But by that time, most of the Unix vendors were beginning to distribute their code to their customers only in binary form. The engineers at Digital, including myself, got to see the source code, but the customers that received it typically did not, unless they had a source code license from AT&T, which was very expensive. So most people did not get that, and they instead used the binary-only versions of the code that came from DEC. Now, in 1994, I met this young man named Linus Torvalds, and I saw Linux for the first time. I saw the power of having this Linux community, and I started promoting Linux inside of DEC and outside of DEC. I got the first 64-bit computer system that Linus Torvalds ever had, and I helped to put together the engineering staff that created the 64-bit port of Linux from the 32-bit Intel version to the 64-bit Alpha version. Now, back in those days, up until the time I've been talking about, machines were very expensive. They used a lot of electricity and air conditioning. A lot of them were built on raised floor with the cables running underneath, and they used water cooling to keep them cool and things like that. They used proprietary software that was extremely expensive by today's means. And the distribution of the hardware and the software was also expensive. You distribute the software on magnetic tape, and the magnetic tape sets might cost you $1,200 US. The marketing of hardware and software was expensive. Typically, the marketing costs and the cost of sales, as we said it, was about 36% of the price that you paid for the software. So if you paid $100,000 US for the software, $36,000 of that would be credited to expense of sales and marketing. Companies had big trade booths and things like that. The internet did not exist. So if you wanted people to know about your hardware and software, you had to buy magazine articles and things like that. So if you went to try and create a new product, raising the funds to buy the computers, to buy the software advertising, to buy, to do everything was extremely expensive. And you had to go out and get people who were known as angel investors to be able to come in and look at what your idea was, give you a little bit of money, get you to a certain point. Then you might have a prototype, and then you'd have to go out for more money, and so forth and so on. So the whole thing was incredibly expensive and time-consuming. But now, you can have very capable machines, like a Raspberry Pi, for $35 US. Oh yes, you have to add a power supply and a monitor and things like that, but you can actually build a machine capable of doing significant work for under $100 US. And today you have more and more hardware which is completely open, so you can write device drivers for it. You can make a solution that people want to buy. If you go out to the web, places like SourceForge and GitHub and GitLab and various project sites, you can find that there's over 400,000 free and open source projects and ideas and parts of an idea that you can utilize to make your solution. And it's not just about the software or even the open hardware. There's a free and open culture that goes around this. If you need music for your product, or you want to have artwork for your product, you can find lots of it out there that is available under open licensing to allow you to use it and make a very beautiful product right off the bat. And there's also very interesting ways of raising money to continue to make your prototype into a finished, polished product. Things like Kickstarter and Indiegogo and other crowdsourcing techniques. And if you have a prototype, if you have something that you can show people to show them what your idea is, then it's a lot easier to get them to commit their money to buy your product in the future. They also know that you're partially there already. It's just a short hop to the next step of you being able to deliver them perhaps a hardware and software combination product. So this comes back to, what do people really want? And I've been telling people for years that people don't really buy hardware and they don't really buy software. Back in the early days, you might do that. When you were going to write the complete product, the complete solution yourself, you might buy a computer system and you might buy an operating system. But these days, people don't care about that. What they want is a solution to a problem they have. And that is what you're actually selling them. So here are some solutions that you can put together with existing free and open source software, hardware, and things like that, to have something that you could sell to somebody, either the entire solution package or support for that solution or whatever. And I'll go over each one of these in turn. So the first one is called Odoo. And this is an enterprise resource planning system, ERP, which does things like inventory control and customer relationship management control and accounting and lots of other things this can do for you, utilizing plugins that plug into a backplane known as Odoo. This is a free and open source backplane. There's a community of people who work on this, as well as commercial people who work on this, and you can get either free plugins or plugins that you pay for to run this system. Now, in addition to the enterprise resource planning, you also have something known as a point of sale terminal. And here in the picture with the guy with the yellow shirt is a point of sale terminal. You've seen them before. You go to McDonald's or you go to a small supermarket and you're checking out, and there's a person with an LCD panel, and they have a scanner, and they have a scale, and they have a printer, and they have, a thing that you stick your credit card into to pay. And this is known as a point of sale terminal. And using the Odoo system, you could program a point of sale system and sell it for a fraction of the cost that somebody might pay for a commercial system, like from somebody like Oracle or one of the other commercial vendors. And if you look at the chart to the right, you'll see that Odoo, as far as ease of use, ease of programming, and functionality, is way up there in the corner. So you have a lot of the same functionality that you might get in more expensive systems, but a lot of these more expensive systems are also harder to use, harder to install, harder to change, because you don't get the source code for them. And Odoo is a good system for that. Now, another system that you could use is something called Kodi TV. And this has had a wide range of different names over the years, but Kodi TV is its current name. This basically allows you to set up a smart TV, but I like to say a smart TV on steroids, because it allows you to hook together all sorts of devices, your phone, your computer system, and things, to share the videos and movies and all the different types of media that you might want to look at and view, including your music, your audio. You can hook in your own amplifier system, and then you use a small single-board computer to be able to mix the music, to control the music, to control the video. It also can act as a first connection to the internet. If you have somebody that has no connection to the internet, but they don't have the money to put together a highly sophisticated computer system, you could use this to give them both a multimedia entertainment system and a connection to the internet, so that they can enjoy the benefits and value of the internet. Now here's an example. These are some screenshots of the main features of Kodi. So you can set up a recorder to record over-the-air TV. By using certain USB tuners and things like that, you can capture over-the-air TV using the different protocols, like the Brazilian protocols or the Latin American protocols, as well as US protocols and so forth. This works not only with over-the-air, but also with cable TV. As long as it isn't encrypted, you can capture it, you can play it back, you can record it. So, this shows you how you can use music and your video and things like that. It's really a wonderful system, and people will pay you to install it for them and tune it for them and get it set up. Now, I've mentioned over-the-air TV a lot, and if you're in a big city, say like Sao Paulo or New York or Boston, there's a lot of TV stations that are still broadcast over the air, and this allows you to get free TV and free news and things like that without having to pay money to a cable provider. This will require a tuner card or USB tuner that are readily available off of the internet, and you can actually set up a back-end server system like Plex or MB or others to allow you to share the data, the videos and everything, the music and everything, with as many systems in your house as you have. You're also able to use remote controls, either the typical remote controls that you get with a TV set, or you can use your smartphone. It has a both for iOS and for Android. It has the ability to set up a control system and use your smartphone to control what's in your multimedia system. You can even use your keyboard and your mouse to control it if you're just sitting there, with your keyboard and mouse in front of you. And certain game consoles are also supported as a remote system. Now, with all of that, we've just been talking about the single-board computer, like a Raspberry Pi or, a Labrador or something like that. But you can also go out and buy a nice digital amplifier and stick it in the system. It's easy to integrate this into your existing SBC and Kodi system. And you can either use an LCD panel or one of the other LCD, large screens, or you can use an LCD projector to project onto a wall or onto a screen for wide use. So that's Kodi. The next thing I'd like to talk about is FreedomBox. About 12 years ago, a friend of mine, I like to think of him as a friend, decided that there was some problems with the current use of things like you get Facebook and things like that. And he decided that he wanted to set up a program to create a very inexpensive and secure gateway or server that would use a single board computer. And he wanted it to be a personal server or a community server. And he wanted it to be able to be easy to use to set up through something known as a dashboard. So you could even hook up disks to this or a NAS device to this and share your disks amongst your systems in your house. And it could act as a server for what we call Fediverse.party applications, which allow you to set up a Facebook type of service or a Twitter type of service, but without a central point of control. So it's much more secure, much more private. And Eben Moglen was his name, or is his name. He is a professor at Columbia University. He is also a lawyer, and he actually wrote the first version of the GPL version 3. So the name of the project is FreedomBox. As I said, it was started about 12 or 13 years ago, and about 2 or 3 years ago they came out with version 1.0 of their services. Now, there's another thing you could go after, which is home automation. And HomeAssistant.io is a home automation package which has thousands and thousands of people working on it and thousands of different devices which you can control using Home Assistant. Now, Home Assistant can be used to save electricity and give you more flexibility in the way that you use your house. It can help you increase security by setting up triggers and things like that. But unlike Google Home and unlike Alexa, it is local control, which is in your house, either being using a single board computer or especially purchased computer from the Home Assistant store, and it's not controlled in the cloud. And so here you see a little picture of the dashboard set up for Home Assistant. You can have a picture of your house with all the rooms, electrical outlets, lights and things like that, and you can see that they're controlled by this. And it's one thing to say, oh, we're going to control our home with this, because there's only so much money that people will put into the automation of their home. But the same software could be used in the automation of an office or the automation of a business, where many more devices could come into this and could recognize a large amount of savings of electricity and power and cost and security from a business. So you could set up your own business of selling this type of automation, not only to people's homes, but also to their offices or their businesses to make money. So these are different packages that exist today that you could use to set up your own business to make money, to give support. And all the packages which I showed you in the last few slides can be set up on a single board computer or a leftover laptop or a smaller computer. They don't need a lot of CPU power. Now, the areas to watch in the coming future are things like RISC-V architecture. So everybody's familiar with Intel and AMD. Those are what we call complicated instruction set computers. For every machine language instruction which is executed, there's lots and lots of tiny little instructions which we call microcode, which are executed to do whatever you want to do. With a reduced instruction set computer, typically every machine language instruction does only one thing inside of the computer, and therefore they're executed many tens of thousands of times faster than a CISC computer might be. It's not to say that the RISC is faster than the CISC. It just means to say that for every machine language instruction, it typically does one thing. Now what this does is make the actual chip less complex. It makes it smaller on the piece of silicon. It means that it may generate less heat, and it means you can have many more chips on a single piece of silicon coming out of the foundry. So over the long run, this might make a less expensive CPU for it. In addition, a project called RISC-V, which developed out of the University of California, Berkeley, the same people who made Berkeley Unix, is a new architecture that was started from scratch for people looking to say, oh, we've been doing computers for 60 years now. What did we do right? What did we do wrong? And let's create an architecture that starts with a very, very simple core computer that has a few instructions that can run any operating system. And if you want to extend it, if you want to make it more powerful, you can extend it through extensions to the operating system, perhaps for GPU, perhaps for an FPGA, those type of things. And so it's called RISC-V. You can see it on the net. There's a huge number of companies that are participating in the RISC-V architecture, the development of it. You can actually buy RISC-V systems today. They may be not as fast as the current Intel processors and things like that, but they will get faster over time. And this is a very good thing to watch because this is completely free of licensing. If you want to go in and make your own RISC-V processor, you can do that, which will allow many countries to go in and set up their own fabrication plants to be able to produce these chips in their own country, which will help with supply chain issues and also help with security. So that's one thing to watch. And you can do that even without joining the RISC-V association. Everything is open and free. You can see that. A second thing to watch is high-performance computing, what some people call HPC. Originally, around 1995, these were called Beowulf supercomputers. But they continue to roll out with a continuation of things that are really interesting in projects. Things like the Webb Space Telescope use high-performance computing to be able to analyze some of the pictures coming back. So that's always an interesting thing to watch and learn how to program in parallel for these type of systems. Cybersecurity, of course, is a much looked at area these days. Lots of money being spent for people who want to learn about cybersecurity. And free and open source software have a lot of distributions, a lot of different projects which go into cybersecurity. You can learn about this online. You can then take certifications for it to be able to show to potential employers that you know about this. It's a good area to go into and to watch. Artificial intelligence is another area to watch. A lot of this is being done with free and open source software, being done in an open way, and is progressing very fast. I look at artificial intelligence two ways. I'm very interested in it, and I'm also terrified by it. Every time I hear somebody say, well, an AI system is never going to replace my job, I just go, you just don't know what you're talking about. That there's no reason why a machine cannot become as intelligent as a human being, any human being. And the reason I say that is because our brain is made up of a bunch of synapses and neurons, which are the same thing as network connections and memory cores or memory units. And it's just a matter that we just don't know how to do it yet. But sooner or later, I have great faith that we will have a artificial intelligence system, which I tend to think of as inorganic intelligence, that will be every bit as smart as a human being. And in my heart of hearts, I hope they learn how to keep it unplugged when they need to. And finally, we have quantum computing, which is a very interesting emerging science that people should study. I'm quite happy to be 72 years old now, and I'm hoping I'm not going to have to learn very much about quantum computing in my final years. I'll let the younger people do that. Thank you. So with that, I will open it up to questions, and I thank you very much for listening, and I hope you enjoyed the talk.